webinar. So yeah, my name is Karthik. So I'm the founder and CEO of Mydbops, and I have around 11 years of experience in MySQL and its related technology, and I have worked in Yahoo before. So coming to Mydbops, so it's a 5-year-old organization, and we support various organizations in the Indian subcontinent and abroad also in US and Gulf also. And we are one of the certified AWS partner, and we are also a PCA compliant one. Yeah. So when it comes to MyDBOps services, these are two things we do. One is the database consulting services, and other is the managed database services. And we provide this support and services for the top three databases like MySQL, Mongo, and Postgres. So initially we started as a MySQL shop, and then later we adapted MongoDB in 2017, and we got adapted the Postgres in 2020. Yeah. So yeah, so this is my audience. Yeah. So let's get started. So MySQL HA solutions. Everybody loves a HA solutions. So everybody loves HA solution. So availability matters in all the systems. It can be a DB system or the app systems, and the database application. This plays a very major role. So when it comes to high availability, traditionally replication, right, is the one of the major high available solution. Like we call it as the mass slave or the source replica. Now it is called the source replica. That's one of the very basic or the simple method of HA solution. So native replication. So native replication is, as we all aware, it's based on the asynchronous or the binary log based replication. And then there are multiple things can be done in native replication, like you can call it as a master or a master slave or a source now it is aware, or a cascade replication, filter replication. Those things are always possible with the native replication. And MySQL replication is one of the strongest, you can say, even from the very like 5.0. It's very pretty stable. Well, compared to other database, right, we have a native logical replication. That's the important thing. And then comes the group replication. Of course, we have something called NDB cluster. Not going to cover that part. And then comes the group replication. So it it was designed to overcome the problem with the native replication. In native replication, we can have lags. So this was about to try to solve these problems. Okay. Yeah. So what is InnoDB cluster again? Yeah, InnoDB cluster, when you call InnoDB cluster, it's not a single component. It is a combination of multiple components like MySQL shell, router, and the MySQL servers. Of course, with the group replication enabled. So need for MySQL shell. So MySQL shell, as we all know, it's a utility where you can use it and configure the service very easily instead of making a manual installation or a manual configuration. This makes things much simple. And MySQL router is, you can say it's a load balancer, comes with the MySQL, like it works like a TCP level, like a HA proxy. Don't have the SQL intelligence, but it does the job of the switchover and failover really efficiently and gels well with the group replication. So fine, yeah, NodeB cluster and its components. So when I say MySQL servers, here if you observe, I have said servers. It means that there are many components in, like not only a single node can form a cluster, it needs a 3 node, a minimum, to get started. Okay, and they should be running in a group replication fashion. Fine. So InnoDB cluster. Say the cluster, right? They are synchronous replication. It means eventually they will get synchronous, that we will discuss later why it is called eventually synchronous. And they support single primary and multi-primary modes. So you can write from any node and read from any row. So that's what it is. Or you can still use a single node as a primary, and then you can read from all the other nodes where you get the synchronous data set. Okay, yeah. So optimistic transaction logic. So this is something different. It's like this is a feature, you can say. Traditionally, what happens is we acquire the lock and then we make the transaction. But with optimistic locking, we make the write, uh, and only at the time of the commit, we try to acquire the lock. So it happens in the distributed computing world. So as we have in the group replication, right? This is always, yeah, needed. And group membership service. So we call it as a group view. The group view is the exact right time to be made. So group membership services. So when we have a two node, it has such a view or a state. So only based on the view you propose or receive the transactions. But when you add a node or remove a node, these views get changed dynamically. Okay. So that's a group membership service. Transaction ordering. So when you, yeah, transaction, even though you accept rights from multiple nodes, the transaction order is primary. It should be mandatorily maintained, or else you can have conflicts in the data rights. So this group replication also maintains the transaction order. Like even when there is a log or something else, it maintains a transaction ordering, and it ensures that it goes via only that order. Even though we have parallel replication, everything like that, it goes only by the group communication system. This group GCS, this maintain everything, and this is based on the consensus. So consensus, like term, it means it's like an agreement. Like when you propose something like a primary, the others or the reader should accept it. So that's called consensus. Actually it is a political term where it's used in the constitutions and stuffs. Okay, yeah. So here what we used is a Paxos based consensus. Paxos is a way based consent, and we have XCOM. XCOM is the extended communication system. Okay, and as the name itself says, an InnoDB cluster. Of course, it supports only InnoDB engine. As MySQL though it supports multiple engines like memory, uh, MySam, and everything like that. It supports when it comes to distributed transaction. InnoDB is the only engine it supports. And again, it is a software-based replication. Why I mentioned this, there are questions when people from other technology ask, hey, whether you have a storage-based replication, like we have it in the DRDB. It's a hardware-based solution. And when you look at the rack clusters, they have a shared file or other shared storage. So when it comes to MySQL clustering, it's a shared nothing architecture. So it is a software which controls this database replication by the redundancy of the data. And again, it also based on the binary log replication, GCS, and the data is stored and written via only the binary log. And really works good well for the OLTP workload. What it means directly is all the transaction systems can use it efficiently. And what it means, the other side is you can't use it for a heavy reporting system or which involves heavy or huge writes. I mean the bulk writes. And of course, it supports all platforms as MySQL Server. If you, it supports Windows or the Mac OS or Linux, it supports it. But if you look at the PXE or the Galera cluster, which was eventually more popular also, and it supports only the Linux variants of it. So, but MySQL in this case, it supports all these platforms. Even if you have enterprise MySQL and you're in enterprise systems, then you can still use it on your Windows machines too. So, transaction in group replication. So, in a distributed computing or distributed transaction, everywhere, it follows a two-phase commit. Even Galera also does it. So, what are the two phases? So, one is the voting phase, and the other is the commit phase. Okay, so voting phase is where, okay, we like the primary. So primary, when I say primary here, means the node where the transaction originates or the source of the transaction. When you have a three node cluster, when you try to write from all the three nodes, the source of the origination is called as a primary. So it means the applications make the changes or then they are made to commit. And during this phase, during the voting phase, right, it sends out the information to the via the group communication to the other nodes. Hey, I have made a changes to this set of rows. Here the voting is only for the right transaction, not for the RO transaction. RO transactions never comes into the picture of when you say two-phase commit, even though they are transactions. They don't come into the two-phase commit. So these RW transactions, so they get replicated. The first thing is they received the source, other nodes or the acceptors. That's what the right name they call it here. The leader of the acceptors. The acceptors receives it, and they all come to an acknowledgement saying that okay, this change or this write set can be applied without any conflict. Then they give acknowledgement. Okay, we can go for the commit phase. What it here it means in MySQL is your data get received to the relay log, and then it sends a notification. Okay, the data is in the relay log. You can make the commit, and we are okay with this write set change. We don't have any additional different data set here, and we are okay with this write. So and then it triggers the commit phase in the leader. Okay, yeah. So of course it allows the multi-writer mode. Sorry for the typo. And even the quorum has to be maintained throughout for a transaction. So here, what is the quorum? So this is a very generic or very basic formula. How you define the number of nodes? There are sometimes people ask the questions, hey, Karthik, I have 4 node cluster. Now, does it mean that I can lose more number of nodes? No. So that's where the question comes. Is it possible to have a 4 node or a 6 node? What is the tolerance? And actually is it depends on the number of failures you can accept. In general, example, if let's say you can accept the failure of only 1 node, then you should minimum have 3 nodes. So f is the failure number of nodes. So then 2 cross 1 plus 1, it's 3. So it's a number of, if you still want to run a system, functional system with the 2 node failures, then the minimum number needs is 5. Even if you have a 6, you can have a failure numbers of nodes as only 2. So that's what it is. So the basic is 3 and 5 and 7. That's it. People, even if you go for an even number of nodes, of course it can serve the traffic, but it don't serve the purpose of having the increasing number of failure nodes. Hope I made it clear. Yeah. Let's see a small block diagram. Okay, fine. So first it starts with the commit locally. So the write set, right? That's where the write set comes in. So the write set comes in and it can make a commits locally. Okay, yeah. So what is a write set? So I'm repeating the word write set again now. I have to, what is a write set? So write set, if you look at the MySQL replication, right? Traditionally we have a single thread and then we overcome with the database or a database parallelism, and then we come with a logical clock. That's where we group the transactions in the binary log based on some time limits and time ranges, and then you can say write set as a third generation in that case. So what write set says is transactions affecting different rows or tuples can be grouped together. That's what they call it as the write set. Okay. So even can be a same table. If you are there are multiple transactions, it can be updating or deleting records in the same table. So if they are not interrelated, right, the row sets are not interrelated, then they can be grouped together and then applied for the parallelism. So that's what is called as a write set. So when the commit is triggered, and the commit is different from the write set is generated, and then it goes to the other nodes, or the, you can call it as the acceptors. In our case, it's the slave nodes. We can call it as the primary and secondary nodes. And the secondary nodes will make a certification. So the certification process happens. So in the certification process, it checks whether the same set of rows are changed or affected by the other transaction at the same point in time. Here the certification happens based on the primary keys. Of course, primary key is mandatory in the InnoDB. Actually, in the InnoDB cluster, it is so mandatory, without primary key don't work. Okay. So it goes for a certification phase. And if it detects a conflict, right, the certification phase, it rolls back. It rolls back the transaction. Or if there is no conflict detection, yes. If there is no configuration, then it goes for the apply phase, or it gives the commit back to the leader saying, okay, this transaction can be applied. Now, this will be in the applier queue of the secondary nodes. Okay. So, and there is, it's in the, yeah, and then it starts applying locally. So that's it. So the two-phase commit here actually means that the data has received the secondary nodes. It doesn't mean that it just get applied to everywhere. Okay, the apply is locally, and the local apply can differ. What it ensures is the data consistency, because even in case of a crash, you can be sure that your data is present in the other nodes RELA. So that's a very important thing about this. Hope I made it clear. Of course, if you have any questions, anyone can ask it now. Might be in the question Q&A session. This is a important thing. We will discuss further based on this. Okay, fine. So yeah, let me repeat it. So it receives the local node, that is secondary nodes, and in the relay log, and they are applied locally. So now comes the other question. So when it comes applies locally, right, then it becomes asynchronous. So as it is asynchronous, yeah, to an extent, but not completely asynchronous. We will see that. So yeah, the transactions origin the primary, that is a leader, and the leader requests a commit, and then it goes for the write set. The transaction write set is then distributed via the GCOM, and then the certification is made, and then finally they are applied based on the voting. If there is a if there is no votes, or if there is a two odd number of nodes, sorry, even number of nodes, then the voting and the writes failures. Okay, so it's applied to the local node, that is it receives in the relay log, and then it sends my acknowledgement to primary relay saying that okay, we can make this commit. So this small image I put it from the wiki page. So yeah, the coordinator, yeah, and the participants. So you can consider the left hand is the coordinator. So you send a query to commit, it is prepared, and then yeah, just saying yes or no, and then it goes to the other phases for the acknowledgement or the voting phase. In the voting phase, if it is got the acknowledgement to yes, yeah, it goes for a commit, or else the transaction should be rolled back, and then finally it is acknowledged. This is a representation given in the wiki page for the Paxos. Always it's a Paxos based. So in the Paxos, what Paxos is actually is there can be only one leader at any point in time. Yeah, in a distributed transaction, everything is based on the time series or the time clock. So of course, the other can be a leader, but not in the same point in time. Okay, fine. Yeah. So when the threshold increase, of course, I told there will be a lag. There can be lag. So what is the lag we can afford? That is controlled by the flow control. So the flow control is an important mechanism, and it does two different jobs. One is the collecting the statistics of the queues. There are many queues, like the applier queue, we have the applier queue and the coordinator queue and the receiver queues. So it monitors the stats of the those queues, and then when it crosses beyond the threshold, let's say you have 2000 transactions, you can say that okay, I can afford a lag of 2000 transactions, then of course it's 2000. Then when it tries to kick in that limit, or the limit before that, then the flow control kicks in, and it tries to limit the writes. When you consider PXE or the Galera clusters, where it tries to stop the writes, it won't allow any new writes there when the flow control kicks in. But here it tries to slow down the writes. Yeah, the default is the quota mode. So the default is the quota mode, where it tries to reduce the write set size so that it can eventually capture, like say, apply it. It tries to reduce the size of the transactions further and further until the flow control is get released. Okay. So it controls the write sets, that you can say that the write sets in groups, right? It will try to reduce or slow down the writes from the master. It means you will take more time to commit than the actual when the flow control kicks in. Of course, there are ways to tune the flow control, like you can control the size of the transactions, or when is the minimum and the maximum limits which should be kicked in, or what is the percentage of writes which should be stalled. It can be controlled. And the consistency. Of course, the other question comes in. So when you read or write from other nodes, right, will I receive the stale data? So how to control the consistency? The consistency can be controlled. So there is a variable called group replication consistency. So the default is the eventually, and there are many other modes like um, there are, there are many other modes also. Example like when case of a switchover, uh, failure to primary switchover, you have to ensure all the previous transactions that relay log are applied before it makes promoting as the primary. So that's one of the mode, and there are after and before modes also. So there are different modes. What it does is when it tries to read it, right, when you want the arrow to be consistent, when you enable it, right, your reads will wait until the previous transactions get applied to get the very consistent reads. And when you enable it the RW, it ensures the transaction applied locally on the other nodes, the previous transactions before starting the new writes. So this can have latency, but you will get a consistent read across nodes. But when you have very good and fine-tuned system, there won't be of much latency. And one more thing we have to consider is when you're using this group replication or InnoDB cluster, always use a good load balancer. Okay, in our case, I would recommend proxy SQL, or if you are good with router, you can use router also. So these are the two active load balancer supports group replication in, yeah. So let's say the tuning. So what are the tuning applied for? Of course, all the general InnoDB tuning, right? They completely applies for here. Example, your buffer pool size, your log buffer, log file, and transaction flushing, uh, flush logger transaction commit, of course. You can make it as two if you are sure of your thing is that until all the three node goes in the same time, you can make it as two because already the durability is made by the two-phase commit. So, but if all the three nodes goes down at the same time, you might lose a 1 second of transaction. So it depends. So but making it two can give some additional performance boost. And also the replication level tuning, like the parallel replication tuning you can make. And your build log should be row. That is a limitation you can say, or it's good to have a row based limitation. So row based build log and your build log based optimization also can be done. And beyond that, and there is one more thing called group replication message cache size. So previously it was 1 GB and it was hard coded, and later it was made to 1 GB, like the minimum size was 1 GB in 8020. Now in the last release 8021, they have made it to 128 MB. So this is like it catches the recent transactions. All the recent transactions will be there. And beyond that, you can also have the compressions, the messages, right? The group messages, that is the right side when distributed, right? You can compress it and send it via the network. So it use the LZ4 compression, and the minimum size for compression is 2 MB. Like if there is a transaction more than 2 MB, of course, you can try to compress it, and it will send it via the network. That is the group we are calling about the group communication system is XCOM. So that can save you in the network if you feel the network is the bottleneck, of course. And also with MySQL now we have the binlog compression, MySQL 8, that can help. That can help also in those cases because your relay log and all these rights are there. And if you have a huge transaction, I have told you earlier, huge transactions are not a good thing. But if there is a need, and then the huge transaction can be fragmented. It means the bigger transaction is chunked into multiple small things with a common right side or other transaction ID, and then they are applied. We can consider fragmenting the huge transaction also. Okay, yeah. And also there is one more thing called the clone plugin. We have the clone plugin inbuilt, and even the clone that is used when you are adding a new node, or if you want to rebuild a existing or a corrupted node. So you can enable the compression there also as a part of the tuning, so you can make the rebuilds faster. Okay, so let's come to the last slide. Yeah. So best practices, though it claims that multi-primary is supported, it's good to have single primary in most cases. But if you're sure of your application, if you're sure of your application, like you have isolated the rights so that there will be no right conflicts from the application, then single primary, then you can go the multi-writer modes. But single primary is better in most cases, because there are cases where we have seen people using cluster with multi-node rights, but they isolate the rights based on the database level. So if it is it will write to the only to the database A. On node B, it writes only to database B. So the conflict detection will be less. Okay, it won't be there. So avoid having huge transactions, because as we mentioned earlier, that transaction ordering should be maintained. So when there is a huge transaction, then the upcoming transaction has to wait for until this transaction is certified and passed through. And stable network, of course, that matters a lot. So that matters a lot. But if you are feeling that if you don't have a bit unstable network, then try to tune in the timeouts. So we have the timeouts for the health checks and the expert timeouts. So you can increase the timeout a bit before claiming the node to be dead, because in a group replication it checks the node's health very frequently, and when there is no response for, let's say, x amount of seconds, it calls it as node as dead. But if you have unstable network, it's possible to have this kind of latencies. But if you are sure of what you are doing, then you can increase the timeouts, else it will be expelled out of the cluster. And it's more and more stable with 8.0 while comparing to 5.7. 5.7 has very multiple bugs. Of course, they are porting the features back to MySQL 5.7, but it's good to go with the 8 when you want to try a InnoDB cluster area group replication. And always use only with a proxy SQL or MySQL router, because this group replication claims only the replication consistency, but the switchover or failover from the application, right? So it can be done only from our end. So we have to use a load balancer like proxy SQL or router. Yeah, that's all, guys. And thank you. Let's have the Q&A session.